Greetings to you. Welcome to Physics with Ben. In today's video, we're looking at calculations in sound waves, precisely strings and pipes. I'm making use of these textbooks, New School Physics textbook. I was telling you about today's physics. These are the textbook I'm using, and there are other more ones I'm using as well. So, in order not to waste time, we'll begin with New School Physics textbook. Get your calculator set and your writing materials. New School Physics textbook, page 352, exercise 15. Question number 3. Question number 3, exercise 15. I read, a boy standing some distance from the foot of a tall cliff claps his hands and hears an echo 0.5 seconds later. If the speed of sound in air is 340 meters per second, how far is he from the cliff? Data collection. The parameters in this question are as follows. Time t is giving us 0.5 seconds. The speed of sound wave in air v is giving us 340 meters per second. How far in physics simply means distance. So distance d is not given. I want to quickly throw light on something here before I continue. WAEC examiners have laid much emphasis on candidates' inability to do very well when it comes to calculations in physics. If you see me solve any question here, you replicate it exactly the way I do on the board. That is the pattern with which you must solve your questions. I always tell my students there are 5 C's when it comes to calculations in physics, namely, the first C is correct data collection. This is it here. If you don't collect your data correctly, even if you know the correct equation, you will end up getting wrong answers. The number 2 C is correct equation. You don't get any mark when you collect your data. But the other 4 C's are where your marks are sprayed. Correct equation, correct substitution, correct evaluation, correct answer with SI unit, if any. There are some calculations that don't have answers. Don't have SI units. For instance, you are calculating mechanical advantage, you are calculating velocity ratio, you are calculating relative density. We call them dimensionless quantity. If you calculate such and you end up putting SI unit, it then means that your answer is wrong. They will mark you down. However, if you calculate, for instance, the velocity of a moving object, and at the end you don't include meters per second squared, meters per second, the examiners will also mark you down. So next stage is what? Correct equation. The echo equation is given as what? It's given as V is equals to 2d all over t. So if the question carries 2 marks, maybe this will carry half mark or 1 mark. That is how the marking scheme is structured. Please take notes. We are done with this stage. Stage number 2, we want to make d the subject of the formula. So we have this implies that your 2d is equal to v times t. This implies that your d is equal to what? Your d is equal to what? V times t divided by 2. At this point, you will substitute. So this implies that your d is equal to what? Your v is what? 340. Your t is what? 0.5. Divide by 2. If you do that, you are going to have the following result. So we have 340 times 0.5 divide by 2. Do that, you have 170 divided by 2. If you do that, you're going to have 85 meters. Therefore, your D, the distance is 85 meters. This is how you are supposed to present your calculations correctly before any exam body. Thank you. God bless you. Let's look at another question. Question number 6. Still that same page. Question number 6, page 352. Question number 6, I read. A source of sound produces waves in air of wavelength 1.65 meters. The parameters wavelength is 1.65 meters. Full stop. If the speed of sound in air is 330 meters per second, 330 meters per second, comma, the period of vibration in seconds is dash. So your V is given as 330 meters per second. They are asking us to find the period T of oscillation. There are two possible equations we are going to use here. You can say V is equals to lambda times F. And you know that your F is what? 1 all over T. So V is what? Lambda times what? 1 all over T. Or you can go ahead and solve for this, and then find the frequency, and then find the inverse of the frequency in this second equation. So this is equation 1, equation 2. But we are not making use of equation 1 and 2 because you don't have time in the exams you are writing. So we say that our V is lambda all over T. This implies that lambda is equal to V times T. And then your T is given as what? Lambda divide your T, V is equal to lambda times lambda over T, and what do you have here? Yes, your lambda is equal to Vt, and then your T is lambda over V. The time to substitute. If you substitute correctly, you're going to have your lambda is given as 1.65 divided by 330. Divided by 330. If you do that, you're going to have 1.65 divided by 330. Our answer is 5 exponential negative 3 seconds, or 0. This also means or 0.005 seconds. 5 seconds. That is your answer. So we are going to clean this and solve another question. We are solving question number 9, page 353, exercise 15, question number 9, page 353. Question number 9 reads, a ship's echo sounder sends out a supersonic note which is received back at the ship 4 seconds later. Full stop. If the velocity of sound through water is 1,500 meters per second, what is the depth of the seabed? Solution. So the parameters in the question, available in the question, include time, T, is given as 4 seconds. The velocity V is given as 1,500 meters per second. And then the depth simply means D. D is not given. You know that V is equals to 2D all over T, and that 2D is equals to V times T, and that your D is equals to V times T all over 2, and that your D is equals to what? Substitute. You have 155 times 4 divided by 2. 2 here 1, 2 here 2. So you have 1,500 times 2. That will give you 3,000 meters. So therefore, your D is 3,000 meters. As simple as that. So we are going to do more calculations. Sorry, there was a technical issue. I have to fix it up quickly. We are done with this one, and we are going to clean this and solve another question. Question number 22, New School Physics Textbook, page 354. I read. Determine the pitch or frequency of the fundamental and also of the first two overtones of A, a closed pipe, B, an open pipe. If each pipe is 67 long and the temperature is 20 degrees Celsius, full stop. Take the speed of sound at 20 degrees Celsius as 343 meters per second. Very, very simple question. So this is question number 22. The parameters involved in this question are as follows. We have to calculate the F naught. The first two overtones simply means what? F naught. Calculate F naught. Calculate also the first two overtones, meaning for the closed pipe. Okay, this is what I will do. I will collect this data each. Let's collect it for closed pipe. Yes, closed pipe. For closed pipe, I record quickly that this is what you have. That's a wave. A standing wave will travel here, and then the wave will reflect back. The wave will reflect back to this space. The wave will travel this way. The wave will reflect back. Recall in the other video that the distance, this is a loop from this is your antinode, your node, your antinode, your node, your antinode, your node, your antinode, your antinode, and then your node points A, B, hits. So that for one loop from this, the distance from here to here is lambda all over 2. Do you get the distance from here to this point is lambda all over 4. So for closed pipe, we consider from here to this end. So if I pull this thing out, for closed pipe, this is what you have. You have something like this. This for closed pipe. Something like this. So that your end, which is the antinode, this is A. Don't be confused. This is A, B. A, B here is just the length of the standing wave. Antinode, node, antinode, node, antinode, node, antinode, node, antinode. So for the closed pipe, your node is here. Your antinode is here. And this full length, which is given in the question as what? 67 cm. You convert it to meters. You divide it by 100. By 100, and you're going to have 0.67 meters. That is that for that. So the distance from here to here is equivalent to lambda over 4. So you have lambda all over 4. So this implies that your L is equal to what? Lambda all over 4. And if you work it out, it implies that your lambda is equal to what? 4L. So that if you say your V is equal to F lambda and you put this as your fundamental frequency, you end up having your F naught is equal to what? V over what? 4L. V over 4L. That was what we did in the other video. So this is what we are going to do. So what they are asking you to do here in this question is that for this closed pipe, find F naught is equal to what? V over 4L. That is question number A for the closed pipe. Now they're asking you to find the first two overtones. Remember I told you in the other video that the fundamental frequency also means the first harmonic. And in the first harmonic you have 0 over 2. So what you have is that this is first harmonic 0 over 2. And that the harmonics in the closed pipe, they are in odd numbers, while the overtones are in natural numbers like 1, 2, 3, 4, 5, 6, 7 up to n, number of 10. So you have your first harmonic 0 over 2. Now the next thing you have is what? Your third harmonic. Your third harmonic is the same thing as what? First over 2. The next one is what? Fifth harmonic. Your fifth harmonic is the same thing as what? Second over 2. So this is what they are asking you to calculate in the closed pipe. So here what you have is that you multiply 3 by this value. So this is 3 times V over 4L. This is 5 times V over what? 4L. This is what they are asking you to do in this question. So we will begin with F naught. You need to find this. So our F naught for this guy is given as what? The velocity of the sound wave is given as what? Is given as what? V is equal to what? 343 meters per second. Do you get? So we're going to convert this by using this one right now. So we have V over 4L is the same thing as what? 343 divided by 4 times 0.67. If you work it out, you are going to have 343 divided by 4 divided by 0.67. If you do that, you're going to have 127.98. You have 127.98. 127.98 hertz. That is that for that. So since we are done calculating this, it is very simple to obtain the other one. Do you get? We have gotten this already. So for the first harmonic, that is for 3F naught, which also means the first overtone, just say 3 times this value here. 3 times this value. If you do that, you're going to have 127.98 hertz. So the answer times 3 will give us what? 383.95. We have what? We have 383.95. 383.96, sorry, 0.96 hertz. So this is the frequency of the first overtone for a closed pipe in this question. The next one we have to look for, we have to find is the second overtone, which is the fifth harmonic. So we have 5 F notes, which also means F2, means what? 5 times this answer. 5 times what? 1. 5 times 127.98 hertz. If you do that and you work it out, you are going to have 5 times 127.98. The answer is 639 639.9 hertz. This is your F note. This is what the question is talking about. So we are going to do this for the open pipe. We are going to do the same for the open pipe. This is what you are requested to do in the question. I'm going to play this screenshot quickly. So for the open pipe, what do you have? For the open pipe, you go with this, If you pull this out, you have something like this, that look like an hourglass. You up something like this. Yeah, this is what you have. So this is your. If you pull this out, so your node is here, your antinode is here, your antinode is here. So for the closed pipe, the length is given as L, and it is a 67, which also cm, which also means say it are the same length, also means 0.67 meters, and the wavelength is equivalent to lambda all over 2. Please watch the other video, lambda over 2. So this implies that your L is lambda all over 2, and from V is equal to F times lambda, we have V is equal to F naught times lambda, and because lambda is from here, you can also see your lambda is equal to what? 2L. So it implies that your F naught is equal to what? V all over 2L. So this is for the open pipe. So for the open pipe, your F fundamental frequency, which is also the first harmonic. For the first harmonic, you have 0 over 2. So we're going to calculate this first. So what do you have? The speed was given to be 343 meters per second. So you have V is equal to V over 2L. So you have 343 divided by 2 times 0.67. If you work it out, you'll be having 343 divided by 2 divided by 0.67. Our answer is simply 225.97 hertz. So this is the fundamental frequency, also known as the zero overtone. This is the fundamental frequency. And recall in the other video that I sang the song that the fundamental frequency, also known as the vibration in one single loop or one segment, is given as this, and this also known as the first harmonic. First harmonic, 0 overtone. So second harmonic is equivalent to what? 2 times V over 2L, which also means what? First overtone. So third harmonic also means what? 3 times V all over 2L, which means what? Second overtone. So this is what those guys want you to do for the open pipes. For the open pipes, those guys want you to to look for this and this. So we are calculating for the two now. So for the first overtone, which also means second harmonic, we have 2F naught, which also means first harmonic, is equal to what? 2 times B over what? 2F. This is the same thing as what? 2 times this answer. 2 times 225.97 hertz. If you work it out, you are going to have that times 2. You're going to have 511.94. You have 511.94 hertz. That is what they ask you to do for that. 511.94 hertz. For the second overtone, which also means third harmonic, you have 3F naught, which means F2, which means 3 times F naught. 3 times this result in F naught. 3 times 225.97 hertz. If you do that, you are going to have something like this. You have 3 times 225.97. If you do that, you have 677. You have 677.91 hertz. 0.91 hertz. This is what they ask you to do in question number 22. Question number 22. We see to this we have come to the end of today's calculations in strings and in pipes. We are still going to produce a video on this. See you in another video. God bless you.